We are here in sunny Glasgow, as you can see, and we are working on SynaesthetiQ. We're working on our first sort of test of the full hardware. This is not software complete, but we have got our... Oh Christ, I need to make sure this is centered. I could have done this before you were here. We're working on this, which is one of our earliest SynaesthetiQ hardware tests. And we've now got both our big LED and our matrix, so we can show them both off. And they are running on a Raspberry Pi like the final hardware, although this is a Pi 0. The final hardware will be a Pi 4B. I think I'll just light it up a quick sec. This is it in blue. This is it in purple and turquoise. This is because of an issue. This LED is RGB, whereas this LEDs here are GRB, hence why red and blue and green and blue are the ones that are lit up. We're going to fix that, obviously, in software. This is it in full white, and I'll turn it off. Now, when we first started testing this, we actually ran into an issue on the Pi, where thanks to the clock frequency of the Pi, we were actually not able to output color data correctly. And what was essentially happening is the SPI frequency is driven from the clock frequency of the CPU. This is normally not an issue because SPI has a clock signal going alongside it, but these WS2182 LEDs or whatever they are don't actually use a clock signal, they are self-clocking. And because the CPU frequency changes, the SPI frequency changes. And this is just because modern CPUs do CPU scaling where they speed up and slow down to save power. So we had to disable that in order to get a consistent SPI output, which is now allowing us to drive all 513 of our LEDs here. Yeah. Also worth noting the feeds and speeds on this, actually, if we go and have a quick look. Yeah, so we're in white now. You can actually see here, we're using nearly 2.5 amps at 12 volts just for the top LED. And then if we go and look at our other power supply, we've actually got oh, that's not even running at full. Oh, yeah, that's running way below full. I hadn't realized that. Yeah, so this is running dramatically below what it's supposed to be because these are 3.7 volts where they're supposed to be 5. And it's supposed to be 5 amps at 6 volts. No, 6 amps at 5 volts. That is the frequency, that's the current draw we're testing at because we don't really have any power supplies that can actually supply that. The final device will actually be running the matrix at 10 amps, not 6. So it'll actually get even brighter than this as well. Yeah. Have fun.